Hi, today we're going to do a simple experiment of quantifying the rate of osmosis. Osmosis is nothing but uh, water molecules moving from an area of higher concentration of water into a area of lower concentration of water. Of course, it's going through a semi-permeable membrane, and once again, there is not going to be any external energy applied. So, for that, we're going to have a beaker filled with water. It's about 100 mils, and I'm going to use my dialysis tubings. Um, and then we have a refractometer to determine the sugar. So we're going to put sugar solution into the dialysis tubing. This is a refractometer, and I'm going to first fill up the well with distilled water. You want to make sure no air bubbles are in here. Turn the machine on, and you want to press 0 to make sure it is showing you 0. Basically, we're just again spanning the equipment. You also want to ensure that it is showing you a bricks percentage on the top. If it does not, then you want to switch the range, which is, it's a dual equipment and it can give you the refractive indexes as well. So you want to make sure it is showing you percentage bricks, which is the unit of sugar. Using the paper towels, skim wipes, we just, not paper towels, skim wipes, we gently wipe off the liquid from the well. And I'm going to take the sugar solution which we are going to use. It's like the virgin sugar solution or the starting point, and we fill up that well and we press read. When you press read, you're going to get a sugar concentration which shows me to be 29.5%. That's something what we generally target, around 30%. Once you have got that, you're going to note that down. That means at 0 time, the reading was bricks percentage was 29.5, sorry. So you're going to wipe that off. During your experiment, you would be asked to do it in 2 different, so you're going to put the 29.5 for both the values. Now, the dialysis tubing was soaked in water, and initially, like we said, just twist it and then tie it. These are the things which I see students really struggling with, but it's not that difficult. You just want to tie it out nice and tight. You want to make sure that there is no leakages happening from this knot. We know our starting sugar solution is 29.5%. We're going to take in about a dropper full, which typically I've checked is about 3 mils. And there are some which have markings, and you could use that as well. I'm going to fill that up to about 3 mils. I know my starting is 29.5. The trick here is to keep in mind that wherever you are putting your sugar solution, after 30 minutes, you're going to take the reading from that particular location. In this particular case, we will have to snip this after 30 minutes and take because water is going to go from here into there. So that's what's going to happen. And we're going to dunk it in. You take your timing and you don't give it a stir after that. 30 minutes are just up. I'm going to pick this up. So in 30 minutes, some amount of water from the beaker has gone into my dialysis tubing. It's a movement of water. I'm just going to cut that out. I'm going to I'm going to take readings from here. I'm going to dunk that in there and turn it on. And since we have already spanned this equipment, we won't need to span it again. We're just going to press read, and I get a value of 8.6. So let's have a look. We started with 29.5. After 30 minutes, that 29.5 has gone down to 8.6, which is quite a significant drop. I'm going to pick that up and going to just dunk that in. And this is what I'm trying to do, is like a forced equilibrium. In this lab or this experiment, timing is critical. That means 0, we started the 30-minute, we got a reading, and in forced equilibrium, I have no idea of the timing, but let me see what value I get. So I'm going to just make sure I get a correct reading, and let's have a look at this one. So we need to wipe that off and fill this well again and press read, and whatever reading we get, it's 1%. So I'm going to type in put in here 1%. Hi, so let's recall the readings we just noted down. Let's write down this as x-axis and this as your y-axis, and in the x-axis we shall put in it as time, and this one is the bricks reading or the sugar percentage. Now if you recall, at 0 time the value of our bricks reading was 29.5, and then at 30 minutes time the value of our bricks percentage went down to 8.6. The forced equilibrium is something what the time which is needed, and however we got the bricks percentage value at 1.0. So basically what we have done is, to get equilibrium, we got the value of equilibrium to be 1% bricks. We need to determine what time it would have taken for that to have occurred. So let's select these 5 values and go into insert and click on the graph, and if you see this regression curve which comes down, it also goes to show you this x-axis is our time, the y-axis is the bricks percentage, and you can see that the bricks percentage at 0 time was 29.5%, and then at 30 minutes the bricks percentage was 8.6. We need to determine what would be the time when the bricks percentage is 1. So all we are going to do is simply click on the curve, and you get both the points highlighted, and if you right click on it, you can add a trend line, and kind of a display appears to your right side, and just scroll down, click on display equation on chart, and if you want you can display the r square value as well. So this is typically a y is equal to mx plus b equation, and I'm just going to write it down. It's not what I'm using to calculate. You will have to use your calculators for doing this. So I'm just writing it down over here for you to understand. In this case, our y is 1 is equal to minus 0.6967 x plus has 29.5. So it's the same as y is equal to mx plus v. I've just put it in an equation. So we need to solve for the value x, and if you take your calculator and work it out, it would be 1 minus, so it would be minus 28.5, because the 29.5 will move over to 1. It will be 20 minus 28.5 is equal to minus 0.6967x, and you then will be solve so minus minus will cancel out and solve for x. The x value works out to be equal to 40.907 minutes. So in this way we have solved this equation, and in that process we have determined the time taken for an equilibration to happen. Once again, this is not this is an evaluated or an extrapolated time, so may not be absolutely accurate, but this is what we determined to be our equilibration or the forced equilibration. I would think that now it makes it easier for you to do the same for the second solution which you would be doing. Thank you.